After obtaining this, I of omega. So I of omega is equal to here. I of omega is equal to, you can treat it as like a input voltage. You can treat it as like a output voltage. So input voltage, always KVL says that voltage, applied voltage is equal to sum of voltage drops. Now what is the current flowing to this one is I of omega. So these two are in series. So applied voltage X of omega is equal to I of omega into Z1 plus Z2. So I of omega is equal to X of omega by Z1 plus Z2. Now we want Y of omega. What is the Y of omega? Current flowing through this one. What is the current flowing through this one? I of omega. I of omega into Z2. Previously we calculated I of omega. What is the I of omega? X of omega by Z1 plus Z2. So Y of omega is equal to I of omega into Z2. What is the I of omega? X of omega by Z1 plus Z2 into this Z2. So finally we are going to get this formula. Y of omega is equal to Z2 by Z1 plus Z2 X of omega. Whatever I have given the explanation, that explanation for this one, he has given directly here. So the explanation is simply, you can assume it is a voltage, input voltage, it is output voltage. The current flowing through this one is I of omega. Okay. Input voltage, output voltage, current flowing through this one is I of omega. Okay. Then after getting this one, you need to write transfer function. What is the transfer function? Y of omega by X of omega. Y of omega by X of omega is nothing but H of omega. So it is nothing but Z2 by Z1 plus Z2. Already we know what is the Z2, what is the Z1. That is going to be substitute here. That is going to be substitute. You substitute here. H of omega is equal to Z2 by Z1 plus Z2. What is the Z2? 1 divided by J omega C2. This usually, this derivation is, if you do with Laplace domain, it is very easy. It is very easy. Compare with the frequency domain, because there is a simply 1 by CS2. Wherever we have a J1 by J omega, that is going to be right like S. Instead of J omega, yes. So we can easily apply. So anyway, you take LCM and you simplify. So finally, it is a H of omega. Okay. It is about the transfer function of the system. Sometimes you may ask the questions. This is usually entirely related to the networks. That is our electrical concept, electrical network. So that is going to be give in the SS or in the PTSP also, because the system is, going to be give, the system is like a network. For that network, there is an input, there is an output. So we need to analyze that network, then only we can calculate this transfer function of the system. So again, this causal system, most of the time I have repeated about this causal system. Most of the time I have repeated about this causal system. So every time in the classroom, the causality means usually the present output of the system always depends upon present input and past inputs. Present inputs and past inputs. It does not depends upon future values. Okay. So my point is, whatever the explanation author to author, it is different. My point is, you see here, we are going to be explained. It is always based on impulse response. My point is, if we consider an LTI system, for that, input is a delta of t. Means x of t is an impulse. So impulse means usually where we are going to be apply input at a time t equal to 0. So that is our present input. What is our statement? The present output always depends upon present input or past history of the inputs. Past history of the inputs means here, whenever we are going to see on graphical representation, that is going to be right time t equal to 0 or after time t equal to 0. Time t equal to 0, present. Past means after time t equal to 0. After time t equal to 0 means delayed case. After time t equal to 0 means delayed case. And usually that meaning of this one, present and past. Past values is here in right side. Future values are here in the left side. Whenever the values are negative, that is going to be future. The values are positive, that is going to be past. That's why we are applying input is a time t equal to 0. We are expecting output is also from time t equal to 0 or after time t equal to 0. After time t equal to 0, not before time t equal to 0. మన input apply చేయక ముందు output రాకూడదు. So that's why we are framing the condition h of t is equal to 0 for t less than 0. మనం apply చేసిన input, where we have applied the input is a time t equal to 0. That's why the output, the impulse response, the output of the system, LTI system, is definitely after time t equal to 0 only. Time t equal to 0 or after time t equal to 0. So that's why we have framed a condition for causality h of t is equal to 0 for t less than 0. It is a valid condition. It is applicable for both signal systems and PTSP also. It is very important. Now, see, it is one more problem as given. Find the transfer function of h of omega for the network shown in figure previous. Here you see y of t, if x of t is equal to e power j omega t. In this case, he has given input and find the output. Find the output. So we know y of t is given here wrongly. Whenever there is a y of t means convolution with x of t with h of t. Now he has given here y of t is equal to x of t into h of omega. It is not h of omega. It is a convolution of x of t with h of t. And if you want to write it is in frequency domain, y of omega is equal to x of omega into h of omega. Okay. Now you see here, it is our network. It is our network. It is the previous problem. Previous in the 5th unit we have done one problem. Now again, I am going to explain this one. Previously also I told you that most of the time he may give the question is in time domain. He may give the question is in time domain. You need to convert corresponding network into the whether it is in S domain or it is in frequency domain. This book he followed with directly in the frequency domain. He is not going with the S domain. Suppose this network has given, suppose it is in the signals systems. Usually we are going with S domain only. Why we are every time we are going to specify this S domain means compare with the frequency domain. This S domain somewhat easy for analysis. So whatever the previous explanation, that explanation is sufficient. Usually if we see the inductance units are Henry. So it is not possible to apply directly KVL here. It is not satisfying Ohm's law at that time. Suppose if you want to write in time domain, it is okay. If you want to write time domain, x of t is equal to, you can write L into d by dt of I of t plus R into I of t like that. So the analysis is somewhat difficult for analyzing it is in time domain. That's why we are going directly for frequency domain. So we can write it is a x of s, SL, R, y of s, and whatever the current is flowing, that is I of s. After writing, you can write s is equal to j omega. So that's why x of omega, j omega L into j omega L into j omega L. It is R, there is no any change. It is output y of omega. Same derivation. If there is a current is flowing, I of omega, apply input voltage. Input voltage is equal to sum of these two voltages. I of omega is equal to R plus j omega L. Then I of omega is equal to x of omega by R plus j omega L. What is the y of omega? The current flowing to this one into this particular resistor. So all these things if you write, that's why you see here, y of omega is equal to R into, he has given directly this x of omega divided by R plus j omega L. How it is going to be get x of omega by R plus j omega L? Nothing but current. What is the current? I of omega is equal to x of omega by R plus j omega L. Then if we take here, R is a common factor, 1 plus j omega into L by R. So y of omega by x of omega, it is a h of omega. Okay, it is the h of omega. Now, if you do it is in time domain. If you do it is in time domain, y of t is equal to convolution of h of t with x of t. Convolution of h of t with x of t. Okay. So better you can go with frequency domain. Better you can go with the frequency domain. From that, you see here x of t convolution with the h of t convolution with the x of t. Now, what is the convolution formula? H of tau into x of t minus tau into d tau. X of t minus tau into d tau. What is the x of t has given? X of t has given it is e power j omega t. So you substitute here e power j omega t minus tau into d tau. So we are doing integration with respect to tau. So this e power j omega t you write separately. E power j omega t separate. Now remaining term, it is the, what is this one? Fourier transform of h of tau. It is h of omega. Okay. I am going to stop this class. You join in the next class. It is about this PTSP. Most of the topics we covered. Better you write all the students, you write your assignments, whatever the data, whatever the questions already I posted in our group, and the concerned material also I posted. So you go through that material and you see that questions. Some of the questions are not as it is, but there may be some related questions. Based on that, you answer that assignment questions. Okay. All the best. I'm going to stop this class.